So today I'm going to talk about creating not only web apps but powerful, secure, modern web apps with LabVIEW NXG web module. So a brand new topic. Before starting on that topic, I'd like to talk quickly about a woman that inspires me, and she has a really great career. Her name is Julie Bayet. She comes from Quebec, like me. She studied in speech and audio recognition, like me. She had a space career, not like me. She spent more than 25 days in space. She's the first woman from Quebec, actually, in space. She's also a business person, CEO at the Montreal Science Center, and she was recently nominated the Governor General of Canada. So a very high title, the highest title you can have in Canada. So I wanted to give her some recognition today. We often, almost always, give credit to men in engineering, but there are also great women that are giants in the engineering world. So let's start with the topic, creating web apps with LabVIEW NXG. At StudioBots, we have many customers where we do desktop applications with LabVIEW involving databases. They want some customer management application, project management application, finance management application. So this involves databases and custom application that I do with LabVIEW because I'm a LabVIEW developer. But in the past years, I received requests more and more often to also have a web application that goes with that system. So, for example, a portal where their employee can come and log in and track their time, or their customer can log in and access some of their information. So what I was doing is just subcontracting that part because I'm not a web developer. And when LabVIEW NXG web module came out, I decided to give it a try and see if I could use it, if it was mature enough to really use it for customer projects. And a couple months ago, we got a real customer project with a request for a web application where the employee could come and track the time and access their timesheet and take photo of the receipts, all that kind of thing. So I was, okay, let's do some investment and try NXG web module. And if it doesn't work, I hire a web developer. So the conclusion of that is that it worked, and we meet 100% of the customer requests. The application is deployed and used every day today. So it was a real success, but it was also a real pain to get started because LabVIEW NXG web module is a very young product. There are still a few users. I'm not a web developer, so there are definitely some concepts that you need to be aware that are not really applying to desktop application or regular LabVIEW test applications. So I wanted to give this session because I want you to avoid all that pain. And when I say all that pain, it's probably weeks of pain, research, troubleshooting. So I'll give you in a second a link where you can download the slides of this presentation, but also all the code that I will show you, which involves NXG code, LabVIEW, regular current gen LabVIEW code, the database things, everything. There is a 31 README pages that guide you through all the detailed steps. If you want to get started on a web application, definitely go download this and start from there. Don't start from scratch. I think I give you really the base project to get started. So if there is one picture to take today, it's this one. That's the link. It's already live. So bit.ly/NIWeek 2019-web app. I think it's case sensitive. I'll show it again at the end of the presentation. So very few words of StudioBots because you're here for hearing about web apps, not StudioBots. We are an alliance partner based in Quebec City. We are also DQMH trusted advisors. We do LabVIEW development, not a surprise, consulting, training. We have some products on the NI Tools network. VLT is our most popular product for centrally manage your deployments, license your application, and track the usage and errors of your applications remotely. And tools to generate LabVIEW controls from images and have the colors detected automatically and change the colors of your images and create the buttons. So today we will talk about a web application that involves a test station that basically perform tests and saves the results into a database. So a very common use case. So it can be a LabVIEW application or whatever application that saves results into an SQL database. So then we have a server with the SQL database, and we will have some web services that make an intermediate layer to the database between the web VI and the database, and the web server that hosts the web pages. So keep in mind that the web VIs don't run on the web server, then they run in your browser. They run in Google Chrome, Edge, or whatever browser you use. So you could wonder why not communicating from the web VI directly to the database. We could eliminate this big web service layer. There are many good reasons for that. Never expose your database on the internet. It's not secure at all. It's easy to break. And people could get access really to all the data, the core data. So with the web services layer, we kind of reduce the amount of information you can make available. Another good reason is there is no database connectivity toolkit for NXG web VIs. And I think the reason is that it would not be secure. So let's avoid that. So we will have to deal with web services developed in regular current-gen LabVIEW. So the test station, the database, they stay behind the firewall on your local network. They are never exposed on the internet. And what is exposed on the internet is are the web services and the web server that are accessed from the client browser. So I'll start with a demo of the web application we are starting today. There is also a link if you want to try the demo on your browser. It's currently hosted on SystemLink Cloud. I don't know how it will survive if everyone in the room try to access it at the same time, but should be. So our application, so this is currently running in Google Chrome. We want a secured space where not everyone can log in and access our test measurements. So we log in, we have a very simple menu, my account. So I logged in as the NIWeek user, so I have some information about me, my first name, last name. Of course, I can modify this information, and when I modify this information, the web VI running in the browser is going to send a request to the web services. The web service is going to make a local query to the SQL and save the changes to the SQL database. So, of course, if I come back, it's persistent. If I go to the test results sections, that's where I can navigate through the test results of my test stations. So we have, in this example, 5 test stations that register test results in our system. You can see I'm leveraging here the new data grid control that comes with LabVIEW NXG. So all what I have to do is just populate the table, and then I can group by test station, by result, by measurement. I didn't have to code anything for that. It's all built in the LabVIEW data grid control. So basically, whenever we change the test station, we make a request to the web services, which make a request to the database, get the results from the database, and send them back through the web browser. You can see that this application is responsive. It's flexible. So if I navigate on a browser, instead of having the test station list and the test results in row, now they are stacked in column. Also, the data grid control was reduced in size, so I can see all the control on my device. If I navigate in landscape mode, you can see that now we extended the picture at the top. So again, I didn't have to code anything for that. I'm leveraging the flexible UI that comes with LabVIEW NXG web module. And of course, at the end, we should log out. So this application involves a database. We have a very simple database. We are using MySQL Server, but you can use Microsoft SQL Server, SQLite, whatever you want. MySQL Server is really powerful. It's free, so that's what we use. We have 3 tables. The table user accounts, that's where we store basically the user's information that are allowed to access our system. We have the test stations table that lists the test stations that registered the results, and the test results that list the test results for a particular test station. So you can see this relationship between the test station ID and the ID test station in the test results. So very basic SQL structure. So we need to communicate with this database. Remember, not from the web VI, it's from the web services and from the test station. But we don't care about the test station. We know the test station works and saves results in our database. So we want to access this database from our web service. So we will develop in LabVIEW CurrentGen database library. So in this example, we are using object-oriented programming. We found out it works really well for database. We basically create an object per table. So we have an object for the test results, the test station, and the user account. And for each object, we have two methods. Deserialize, which converts basically the data that comes from the database, from the SQL, into a LabVIEW object, and the serialize method, so I can reconvert my object, my LabVIEW object, back to an array of strings that I can then put back to the database. So the DB objects and the queries. So the queries, we have useful queries for each of the database objects. Get all the test stations, get by ID, edit, new, delete, very common use cases. So if I take the example of the deserialize method for the test result, you can see my class has the same field as what I have in my database table. And what we get from the database, the NI database toolkit, for example, is an array of string. And each element in my array is an element of my object. So I take each one of them and I convert it to the proper LabVIEW data type. So in the end, I have a test result object with the proper data types and the information coming from my database. The opposite method is the serialize method. I take my object and I convert it back to a 1D array of data. So we can convert our data back to the database, to LabVIEW objects. We need to open and close a connection to the database, so we use the NI database connectivity toolkit. You specify the address of your server, the port, the database, the username, the password, and very easy and straightforward. Then we want to make some queries to our database. For example, get test results by test stations. There are seats available in at the front if you want. So again, we do a select query. On the test results table, we have an SQL condition where the ID test station equal the one we specify. We get a two-dimensional array of database variants that we convert into a two-dimensional array of strings. So each row in my 2D array is a record of my test results database. So then in a for loop, I use my deserialize method, and in the end, I have a one-dimensional array of test results that it's easy to manage. So you should have everything now to develop your database driver and communicate with your database from LabVIEW. Now let's look at the web services. What's a web service? It's an endpoint that basically provides a communication mechanism to web clients. So what happens is that the web client make a request to the web service processes the request and send back the reply. It uses HTTP protocol, and usually we exchange the data using JSON or XML. The main type of requests you have with HTTP are get, post, put, and delete. There are others, but those are the main, and those are the ones that are used in this example. So the web service processes this get, post, put, delete requests, most likely make a request to the database, and then send a reply which contains the status code. Very important. This is how you know if the request was executed successfully. And it might also contain a body, what we call a body, which is the content. So when I query my web services for the list of test stations, the body will contain the list of test stations in a JSON string. So what happens when I click on my login button on my web application? I do a post HTTP request to the URL where my web service is run, so web service/login. The body of my post request contains the username and password as a JSON object. The web service receives that request, query the database, check the user account stable, verify if the credentials are good. And if the credentials are good, we send the status code 200, which means OK. If you provided an invalid username or password, we send 401. So don't try to reinvent the status codes. There is a list. You can find it on Wikipedia. It's not an absolute standard, but it's still quite standard. So you should be able to find the status code for any of the situation you're facing. If I look in the LabVIEW code now, so that's my web service method for the login. Maybe I'm going to zoom a little bit because it's hard to see. So forget about the core headers for now. I'll talk about them later. So we receive the post data. So it is a JSON string that we will unflatten to get our username and password. We open the database. We get the username, the user account for the username that was specified in the request. Then we close the database. If the username was found, then I'll compare the password. And if the passwords are the same, I'll return this no error VI basically contains the HTTP status code 200, and I send that back to the browser, and I know that I'm logged in. So let's talk about this authentication. There are many ways you could authenticate a user on a web application. One very common way is using the cookies. If you go on ni.com, when you log in on ni.com, it creates a cookie, and this is how the server knows who you are and if you are already logged in and those kind of things. So what's a cookie? Basically, it's a piece of data that the web server sends to the browser, and it's stored on your computer by the web browser. So whenever you receive the cookie, every time the browser sends a new request to your web service, it's going to send that cookie again, and this is transparent. So the web service receives that cookie again, and it basically knows who you are. So the example is basically check if the user is already logged in. If I send a cookie, I can know that this user has already logged in before displaying sensitive information. So how do we deal with the cookies on our LabVIEW web service? By creating what we call a session, a web session. So we use this VI part of the web service palette. You can see that I can specify a timeout for my session. So if I don't receive any requests with that cookie within 5 minutes, the session is going to be destroyed and you have to log in again. So that's what happens. Sometimes you didn't browse a website for a couple of days and you have to log in again because the session expired, the cookie expired. And as soon as you create a session, you can also write session variables. So here I'm writing the account username variable where I put the username of the user that logged in. So when I receive a new request on my web service, I check if a session exists. If a session exists, it means that the user logged in, because the only way I create a session is when I receive good credentials. I check if the session exists. If it exists, I read the account username variable, and I know who is making the request. Okay, so that's how we manage the authentication in the web service. Another security feature that I need to talk about is CORS. Cross-origin resource sharing. That's a pain. Why is that? Why do I need to deal with that? It's because it's implemented by the browser. All the modern web browsers implement this mechanism, which prevents any malicious or any website you don't know to make queries on your web service. So basically, you kind of need a whitelisting who is able to make queries to your web service. So to do that with in every web service method, the login, the get testations, every method, you need to send some headers. That's the CORS headers VI that I mentioned earlier. So there are two headers that are important, the access control allow origin, where we specify which URL is allowed to make queries on your web service. So most likely the URL where your web application is hosted. You can put a star to allow all origins and then it works, it's easy, but it's not really secure. The other header, access control allow credentials, you set that to true to basically tell the browser that to send the cookie to the web service. And we are using cookies for web authentication, so we need to set that to true, otherwise there are no cookies and we cannot store information on the server side. Is there any questions so far? I understand it's a lot of technical stuff on different things that not especially involve LabVIEW, and I could spend probably 10 hours on this session, so I want to make sure you really capture each point. So let's go back to our system. So remember, the web VI performs the query to the web service, and then the web service requests the database for information and return the information to your browser. The way you implement your web service method is always the same. First, you add the CORS headers, always. Otherwise, the browsers avoid the request and nothing happens. Then you check if the user is logged in or not. If it's not logged in, you send the HTTP 401 status code to tell the browser that it's not authorized to navigate this page. If the user is logged in, you send back the 200 HTTP code, then you can open the database, read or write your data, you flatten that to a JSON object, and you send that back to the browser. So in terms of LabVIEW code, I'll zoom again. So here we are checking the user account get. So add the CORS headers, check if authenticated. Here we retrieve on the string the currently logged in username. We're going to open the database, get the user account from the database. We get each field of our user account object. We put that into a cluster. We flatten our cluster to JSON, and we send the JSON string back to the browser with the 200 status code. Okay, so that's how you implement your web service method for getting the user account information. So I'll navigate now through the flow of what happens when you navigate to the index page. We call the check auth method on the web service to check if we are authenticated. We get a 401 error and we redirect to the login page. On the login, we call the server login post method. We send the username password. If it's correct, we receive the HTTP 200 and we redirect to the index page. If I go to my account, I call the web service method get user account, and I get my HTTP code and I can display the account information. If I modify some information, now I send a post request to the user account web service, and the data will be modified by the web service in the database. I go back to home, I go to test results, then I'm going to send the request to teststation/all to get the list of my test stations. And then if I select a particular test station, I'm going to send a request to my web service, test result / the ID of the test station I selected, and I'll receive back my test results that I can display. Now if I click on logout, I call the web service method server/logout, which will destroy the session on the web service side, destroy the cookie, and I redirect the user to the login page. Okay, that was fast, but you have everything. Let's talk now about the web VIs a little bit, because that's what we are here for. I'd like to talk about the flexible, responsive UI. To be honest, I would not have developed a web application for a real customer without that feature. And it just came out today with LabVIEW NXG 3.1. So this is a really nice feature because you place all your controls, you choose which one you want to flexible resize, And when you resize your panel, you can see that some of the controls are then stacked into a column. Other controls like the judge and the data grid resize themselves. So you can browse this kind of UI on any kind of device, and it will always look nice. So very, very nice feature. So now from our web VIs, we need to communicate with the web services, because that's where all the data is manipulated. So we use for that the HTTP palette from the web VI. So that's how we can do our get, post, put, delete requests. So an example, I open a connection to my web service. So I open the HTTP handle, configure these calls, include the credentials. So I pass my cookies from the web browser to the web services. Then if I want to do the login, remember I do a post to the URL of my web service, that method that implements the login. I send my username and password as a JSON string, and if I receive the status code 200, that's fine, I'm logged in. If I receive 401, it means that I didn't provide the right credentials. Now when I want to get the test results, very simple, I do a get query to the test results method of my web service. I receive a JSON string that I unflatten into an array of test results. So you need to program the web VIs in NXG. I decided to use the QMH template because it's a very powerful framework and also easy to understand for any level of proficiency. Someone in the room not familiar with the QMH at all? Perfect. So QMH, we have the event handling loop, managing the user events, and then we send a message in the queue. And in the bottom loop, we have a state machine that will process the messages that we've put in the queue. LabVIEW NXG includes a project template called QMessageHandler for the web. So that's where I started from. Don't use that template, it's buggy right now. So there is a car open, so you can download my presentation. I fixed the issue, and you can reuse that template. But there is a bug in the error handling. So how do I manage the login in my web VI? The first thing I execute in my QMH is the initialize case. What I do immediately, I open a connection to my web service, call the checkout method, and close the connection. The checkout will return an error if I'm not logged in. I receive the status code 401. I'll convert this error, this status code, into a LabVIEW error 501-401. I decided that. I can choose other thing. So I have an error here if I'm not logged in. This error will be propagated, so I never unqueue my message. And this guy will handle the error and redirect me to the error case of my state machine. So here I check the error code, and if this is the error 501-401, it means that I'm not logged in. I'm not allowed to navigate to this web VI. So I redirect the browser to the login page. So I need to talk about this redirect function. I would have loved if in the palette I find a redirect function, but it was not the case. So I had to use a JavaScript library interface. I'm going to talk a little bit about this. So I really needed to programmatically redirect my browser into another web page. So I knew that there was the ability to call JavaScript from the web VI. So I searched, I don't know anything about JavaScript. I searched on Google, JavaScript redirect URL. I found this very small function that takes the URL as an argument and redirects the browser to that URL. So I created a GSLI called redirect. Here I make sure that I include the script that is used by that function. So when I build my application in NXG, that thing will be automatically included in the HTML code of every web VI that calls my redirect function. So I name my function redirect, which basically links to the redirect function of my JavaScript file. It returns nothing, and it takes the URL as a string argument. So once I configure my GSLI, I have a node, a function that I can then use on my block diagram and that takes the URL as an argument. So that's the function that you see right there, and that allows me to redirect the browser to another web page using JavaScript. Question? Good. So now you know how to program your database, your web service, your web VIs. What else? You need to host your web application now. So there are many ways you can host your web VIs. You can use the LabVIEW application web server that ships with LabVIEW since 2009 later. You can use the new NI web server that comes with System Link or the NXG web module. You can also host your web application in the cloud. There is the cloud of NI, System Link Cloud, or you can host it in Microsoft web server or Apache web server or other third-party web server. So everything is possible. So if you want to host your application on the LabVIEW web server, you navigate to the directory of the LabVIEW web server. In LabVIEW NXG, you're going to build your web application. It's going to generate a set of HTML and JavaScript files. You copy all those files in the web server directory, and then you navigate from your browser to the URL of your web server. So I've put the link of all that knowledge base. Very similar for the NI web server. It's just a different path on disk. You copy all the files generated by NXG, and then you browse from your browser. System Link Cloud, it's a little bit different. It takes an NI package. So you first need to build an NI package. So I'll show a demo of this. So we are in NXG. In my project, I'm going to create a new package. Then I drag and drop my web application component into the files of my package, calculates the dependency. You enter some information about your web application. You need to give it a name, maybe put some description, the maintainer, the version, all that kind of stuff. Then on the right rail of the package configuration, moving there, you need to set the target. So we are building the package for a web server, and we are building not a package installer, just a package. Okay. So we are ready to build. You click the build button. On the bottom rail, you can see the progress of the building. And once it's done, we're gonna browse on disk for the result of the build, which is a .ni package file. So then I go to systemlinkcloud.com. I click on Web Apps. I choose my NI package. I upload the NI package that I just created. And that's all. My application is hosted at System Link Cloud. And you can see it's private by default. So if you want anyone to access your application, you click on the sharing button, and you can share it with everyone. Or you can share it with a particular set of users using their email address. So now my application is public, and I have a link, a URL that you can see here that allows me to browse my application on System Link. Yes?
The sharing on the System Link side, is that linked to your database, or is that linked to NI's?
So the question is, does the sharing, when you add the users, does it link to your database or not? No, it's this implementation is the NI security implementation on System Link Cloud. So basically, when you share with a user email address, this user needs to have a user account on ni.com. It uses the email address linked to the user account on ni.com.
So if they don't have a user account, you can't share it with them specifically.
They will probably receive an invite to create a user account on ni.com. So in this particular case, it would be completely redundant because it would be basically two different security mechanisms to access the same application. If you want to host your application on Microsoft IIS, I wanted to make sure I include this information because yes, you copy the files into the directory of the web service, but you also need to add some meme types to the list of supported meme types of your website. It's very straightforward. If I'm speaking Chinese or whatever language you don't understand, it's easy. You add those two meme types. There is the link on how to do so, and then you can host your application on IIS. Very easy. Some very useful resources. So webvi.io, which is actually a webvi. It's a website, but it's a webvi, so you can see how it looks. There are different examples showed here. NI also has a GitHub repository, WebVI example. And there is also this GitHub repository from Milan, I believe, who is working heavily on the WebVIs in R&D. So, sorry, there is this WebVI experiments repo, which is really nice to look at. This is where, for example, you will find examples to take the control of your camera or your microphone from a WebVI. So this is all using JavaScript, but actually someone did the work for you. So I suggest that you visit those repos regularly because they post new examples periodically. So things that I think are missing, still missing in NXG. So it's just my opinion. So we need fully customizable front panel controls. So for example, the timestamp control, you cannot set a format string. So if you want a timestamp control with just the date or just the time, you can't. Okay, so you can work that around with JavaScript, and again there are examples on the GitHub repo to do that. So of course it's a young product, and NI is going to add more and more customization to the controls over the time. Minimum control size for flexible resizing. Right now it resizes the controls proportionally. So let's say you have a string control, and when you navigate on your smartphone, you want to see the string control on full width. It means that it has to be full width on the desktop, which is not nice. So it would be nice if we can set a minimum size, so it resizes proportionally up to a minimum size. So that's also considered by NI, and it should be available actually in the next release of NXG. Variants. If you are familiar with the QMH, you know that we like to pass the message attribute as variants. We don't have variants yet in the WebVIs. They are in NXG for desktop, but not for the WebVIs. There should be available in the next release as well. So what I did right now in my QMH is I just flatten actually my data into a JSON string, and I pass my message attribute as a JSON string. So variants are coming in the next release. Classes, it would be nice if we have classes. There are classes in NXG, but not for WebVIs. So for me, the biggest drawback is that if I have some libraries that I already are using for NXG, and I need to reuse those libraries in the WebVIs, I can't. So I kind of need to duplicate all that code. So that's painful. So again, NXG is a young product. I don't have any timeline to give you, but it's in the roadmap of NI classes. Set UI busy, yeah. So as I said, I developed an application for a real customer. Sometimes there are things that happen in the background, and you don't want the user to interact with your web application while you are processing some data. You could completely mess the application. So you need to set the UI busy with a busy cursor or whatever. So I was expecting to find that in the palette, and it's not there. So fortunately, I found on Milan GitHub repo a workaround using JavaScript, and I don't know anything about JavaScript. I use that out of the box, and now I have a nice animation that prevents the user to interact with my WebVI while doing background operations. Set UI busy, it's in the roadmap as well, but you can use the GSLI in the meantime. File API, right now there is nothing built in that would allow for example, user of your web application to upload a file on a server. So it's in the roadmap, and is it scheduled for the next version? For a future release. I don't have a timeline, but it's definitely in the roadmap. Also in the GitHub repo, there are already some workarounds available using JavaScript. So the really nice thing about this JavaScript library interface is that the possibilities are quite unlimited. And also JavaScript is a very widely used language, so there are plenty of resources available to help you. Again, the link, if you didn't take the picture, that's the link to download the slides, the entire code that I showed today that you can reuse, the 31 pages README to guide you step by step to execute the application. So feel free to download it. Before you go, I would be very grateful if you fill the survey. That's how maybe I prepare a new presentation for next year. And if you are going to GDevCon, I'll see you there because I'm also presenting at GDevCon second edition. And we have time for questions if you want. Yes?
I think I followed how you would take the built NXG web app and put it on IIS server. How do you, I didn't see the connection from the web services that you wrote in LabVIEW. How did those get connected in?
So,
where do they get put? How are they, you know?
So I believe the question is how the web service communicates with the web VI. So those are two different web servers. You're right. Even if I could actually also host my web VIs in the same web server where the web services are running, which would, by the way, eliminate all the CORS issues that I mentioned. So from the web VI, we are using the HTTP GET POST DELETE, the HTTP palette, to make the request to the web service.
But so the web services would get put into the IIS server as executable?
No, the web service run in the LabVIEW application web server. So when you build your web service in the LabVIEW project, you right click on your web service and you do a build deploy, and it's going to build them and deploy them on the LabVIEW application web server.
Okay, so then it's just a matter of the code from the NXG web app is already set up to point at that?
So then the code from the NXG web app, I have a constant VI where I set the URL of the web server where the web services are running, and then I make my GET POST requests.
Thank you.
Yes?
So you're sending a password. Is that encrypted at all? Or?
So the question is, you're sending a password, is that encrypted at all? If I'm not using HTTPS, no, it's not encrypted. So definitely you want to use HTTPS for this kind of application. I didn't talk about HTTPS today because so much stuff to talk. But in the README that I provide with the link, I talk about this in the last section, how to and there is nothing to do in the code. You just need to configure your web server for HTTPS. So basically buy a certificate, install the certificate on your web server, and point to the new HTTPS URL, configure the firewall, open the proper port. So I detailed that in the but yeah, if you as soon as you use HTTPS, then you use the SSL encryption that will basically prevent anyone to sniff your password during the transmission. Yes?
And have you done it because I saw IIS with Apache?
Yes? I didn't do it with Apache. I'm not sure if there is a knowledge base available. Maybe someone from NI can correct me, but I believe it's really straightforward. There is nothing else to do than just copy the files to the web server directory. Yes?
What are your thoughts on the current capabilities of reacting to like button presses or any event handling within the NXG web VIs? What did you find you had everything you needed, or did you find there were things that aren't currently supported that you had to get creative to implement?
So I think the question is how do you believe we have enough things regarding events and user interaction with the user interface? So again, it's a young product, not everything is there. So for example, they just added the tree control. You have an event when you change the value, but you don't have an event for a double click, for example. This is going to come over the releases. So definitely I would check your proper use case before starting. If you really need fancy UI stuff, maybe it's a little bit too early. For my use cases, which is really mostly data management, data browsing, data exploration, data entry, it was really enough. But make sure there is nothing that would prevent you to reach point B. Yes?
How does the application handle multiple
So the question is, how does that application handle multiple users accessing this application at the same time? The answer is very well. So the server automatically handles multiple simultaneous requests. So you just need basically a powerful enough machine. I guess maybe behind your question is how you handle multiple users to modify maybe the same data.
That's the database may manage that. I'm more concerned, do you need to do any precautions in your application?
Any what? In the
Do anything special in your application before?
Depending on your case, yes or no.
Just do it as a desktop application for a single user and don't care about it.
So in this application, for example, each user can modify his own password and can modify his own user information. So there is no conflict. The only thing they can modify in this application is their own user information. Then the test results, it's just a read, so no conflict. If your application will allow to modify some resources for multiple users at the same time, then you will need to implement some handshaking, some security on the server side. By using the cookies, you can know who is logged in, who is accessing what. So maybe you could program some error codes and tell, no, sorry, somebody is already accessing that resource. Wait a minute, or do you want to disconnect the other users? Or you will have to write the code based on your own needs. That answers the question? Yes?
I think part of this question also was you've got the web page, the web services, and then your database. Is there anything special that needs to be done on the web services side or on your web app that needs to be able to handle the multiple or potential high volume usage case?
So all this handling will be done on the web service side because that's really where all the information is centralized. The WebVI runs in the browser, so they don't know about each others and other users navigating your application. It really runs on the browser. So it's really on the web service side. Any other question? All right. Thank you very much for attending. I hope it was useful.